Hello and welcome to my new channel, Mr. Pie the Maths Guy. I've been thinking about setting this channel up for quite some time, and really my motive is to try and get people to see maths as a bit more exciting and not the dull subject it's become in schools. I'm partly motivated by an article I recently read, written last year in The Guardian by Conrad Wolfram. It was titled "The UK Needs a Revolution in the Way We Teach Maths." I'll put a link down below the video if you want to go and read the article. But in a nutshell, Conrad was questioning whether or not we should be teaching the how to do things in maths so much as why we do them and what we can gain from using those skills. After all, do we need to be able to draw a graph to be able to read it? Or better still, does drawing a graph help us read it? Many people over the last few years have been trying to make maths sound more interesting, more sexy, more fun. Primarily because they see that it is. I too am trying in that vein to make it seem a bit more exciting, a bit more interesting. I'm trying through these videos to try and link what we do in schools with the reality of maths, how maths affects our everyday life, where the ideas came from, why did anyone think of this formula, why is it important that we do different aspects of maths in school. But before we start to think about how we do maths, we really need to be clear about what is maths. Well, over the thousands of years, many mathematicians, philosophers and great minds have tried to come up with a definition of maths. All have failed to really capture the true value of what maths is. There was a quote by somebody called R. Drabeck. There seems to be some confusion over who this person is. Nobody seems to really know. They're quoted as having said, "Maths is like love, a simple idea, but it can get complicated." And I think that is actually a really great quote. The concept of maths is in itself quite simple. The mastery of it can and does get complicated. But it only gets complicated insofar as we want it to get complicated. In reality, I often think and say to children, mathematicians are lazy. Think of all the names they use. Actually, they might sound complex, but in reality, they're not. They're a bit like the advert says, a Ron Seal. It does what it says on the tin. And in much the same way in maths, the names often given are just exactly that, a description of what's in the tin. So, through these various videos that I'm going to be posting, I'm hoping that I'm going to be able to show you that actually the concept of maths is quite simple. And actually, if we understand a bit more about why the maths came about, what it's used for, and what we hope to achieve by employing that maths, hopefully the how we do things might become a bit more exciting and a bit easier to understand. Maths can trace its history right back to the very beginning of mankind, and actually some people would argue with animals it goes back longer than that. But if we take humankind of maths, we can imagine our ancestors thousands and thousands and thousands of years ago noticing certain patterns in their life, noticing that certain animals passed through where they were living at certain times of the year, or that certain berries would be ripe and beautiful and tasty and lovely to eat on certain days, but that other times of the year there was none, or they tasted bitter and hard and horrible. Man started to recognise these patterns, and then he started to try and find some way of recording those patterns or managing those patterns so that he would know when a particular animal was likely to be passing through in abundance, or when it was a good idea to go to a particular place because certain fruit would be ready for picking. All of this is just simply man looking at patterns and finding ways to solve the problem of when those patterns will repeat. That's maths in its most basic form. And ever since that day, we have been using that mathematical understanding of the world to try and control our environment, or rather to control our interaction with the environment. Over the years, we become more sophisticated, and that sophistication has led to more deeper levels of mathematical understanding, to the point that the maths we look at now when we're trying to understand the universe as a whole can, for the vast majority of us, seem complicated, and in actual fact, rocket science is probably easier. But what is it about maths that makes us feel we can't do it? Well, I would argue that part of the problem is that we don't understand why we're doing it. So often we're taught how to do something without anyone really explaining why we need to learn it, or where it came from, or who invented it, or even why they invented it. As I've said, through these videos, I want to start to break and chip away at some of these ideas and start to introduce you and children to the ideas of where maths comes from. Why do we need to learn it? But also, I'm hoping that I can help parents help their children by understanding some of the issues that children face when trying to learn maths. Sometimes the issues that we think are easy in maths are actually quite complicated for children. Not because they are complex areas of maths, but because we forget that we learnt these things so many years ago that we've forgotten now that once we didn't understand it either. A great example of this is numbers. We spend a lot of time with our children when they're very young, probably before they even go to school, counting numbers and reciting those numbers, 1, 2, 3, 4, all the way up to 20 or even 100. And then we think, how wonderful, our children have learnt their numbers. They can count all the way to 100. And whilst it's a fantastic achievement to be able to say our numbers up to 100 or 20 or even 50, we need to keep in mind that the children may not be counting. What they're actually doing is reciting. They're reciting an order for number, in much the same way that we learn the alphabet, A, B, C, D, E, F. But numbers is far more than the alphabet. Numbers also have value. We know that 2 is greater than 1. We know that 4 is double the value of 2. But whilst these are obvious facts to us, they're not necessarily obvious to children. Children need to experience that aspect of number. They need to understand that number has a value, that the number 2 is not as valuable as the number 3, or rather has a lower value. So it's through this non-understanding of value that we recognise that children will then struggle with other aspects of maths. For example, if we don't have an assigned value for 2 and 3, how can we begin to really understand that 2 and 3 added together gives us 5? After all, if I said to you that B and C added together gives you E. Would that make any sense to you? And it's that value aspect that really, with parents and children, we need to play a lot more on. So maybe we could concentrate on picking up a number of items and getting the children to be able to say how many there are, and trying to get them almost to do it without counting. So if you put down 2 things, don't go through 1, 2, just go, there's 2 there, and get them to associate the value 2 with the name 2. And then work on that and play around with the ideas. Maybe get 3 1p coins, put them on the table, talk about the fact that there are 3 coins, and then change one of the coins. Maybe change it to a £1 coin and ask, is there still 3 on the table? These may sound a bit of a silly idea, but actually they're concepts that children need to engage with and understand. This is early maths, and if your children really grasp these early aspects of maths, then many other later aspects will probably become a lot easier for them to understand. Well, I've given a bit of an intro to what this channel is about. I hope you find it interesting, and I hope you want to come back and hear some more. If you have any ideas of areas of maths that you're particularly interested in, or that your children are struggling with, or you yourself struggle to understand what it is the children are doing, then leave a comment down below. I'll have a look at it and I'll see if I can come together with some ideas to help you. I'll also put some links in below to do with the article I mentioned and the video series produced by Marcus de Sautoy, The History of Maths, which I think is a really interesting thing to watch. It explains quite a lot about where our maths today comes from. Oh, and one last thing to leave you with. If we didn't have things like numbers and digits and symbols for numbers, how complex would the world be today? How long would your telephone number be if we didn't have simple digits to record it? How would you know how much to pay in bus fare? And things like that. Maths is all around us, not just in school. Thanks for watching. See you next time. In the meantime, go figure.